Good morning, everyone. Thank you for all coming to my talk. I'm really excited to share with you the research I've been pursuing for the last semester with my advisor, Professor Johanna Schmeider, in the economics department. So the title of the research that I've been pursuing is essentially the general equilibrium incidence of a corporate carbon tax swap. That's a lot of words, and they don't really mean a whole lot. So I tried to translate that. I mean, that's what I put on my paper, but that's what I tried to translate into something a little bit more manageable. Essentially, what I've been interested in are the distributional effects of a very specific type of carbon tax policy. And the carbon tax policy that I was examining and testing with the model that I built uses the revenue from a carbon tax to offset a distortionary tax in the market. In this case, the corporate income tax. And so while I think the results of my study are really interesting, I think for everyone else, and honestly what I'm most passionate about is the process by actually which you can go about and analyze a question like this. So my hope for the takeaway from this talk is obviously to share with you my results, but more so just to kind of show you how economists sort of look at how to answer a question like this and tell a good story. So we first start by asking why this might matter in the first place. So the US does not have any federal level climate change policy. And so economists have a really interesting opportunity to explore possibilities before any action is taken. And ideally, you're able to garner enough information about a prospective policy so that you can avoid any misimplementation and adverse effects of implementing such a policy. So carbon taxes in particular are likely to happen in the US if the government does decide to take action to avoid the projected costs associated with climate change, because carbon taxes are relatively low cost to implement, and there's already a pretty significant infrastructure in the US to actually, work with these costs or work with these taxes. And then additionally, why modeling and why the specific approach that I'm kind of looking at here. Models allow for an intuitive understanding of how policies work. The goal is not to predict in absolute terms what will happen when you implement something because no one can really predict the future. But the idea is to understand how policies work and kind of the ways in which they interact, generally speaking, so that you have more information when you go about designing better policy. So the research questions, in sort of looking at this and sort of thinking about the effects and how a policy might impact an economy as a whole, you kind of want to look at the distributional effects, and you also want to make sure the policy is doing its job. Is it actually reducing carbon emissions? And so to look at the distributional effects, we take a look at factor prices like wages, or another example that I'm going to talk about essentially is the price of capital, like machines or other things that firms use in the production of goods. Because depending on how all of these factors change and how they all respond to the tax, we could see some really adverse effects or really beneficial effects to the economy. And additionally, we're also interested in the price of the good that's essentially being taxed. If that increases a lot, we could have some adverse effects on consumers. So economists break down really, really complicated real-world problems into very, 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 very simple models. And in my case, I'm simplifying the entire US economy that's like hundreds and hundreds of firms and many, many sectors into two. And that might seem a little odd, but in reality, this type of model that's been used in the literature before to analyze these types of questions, you actually maintain a lot of the interpretability, the power to interpret kind of what's going on, and you maintain a lot of the dynamics. And that's what's really key here. We want to see how things are sort of changing and moving around. So my two sectors, my two firms, we have a firm that's releasing carbon emissions and one that is not. And other than that, they're completely the same. They produce competing goods that are virtually the same. And the only difference is that one does it with releasing carbon emissions and one does not. And what I want to draw your attention to here is that the firm that's emitting carbon emissions can decide how many units of carbon they actually emit into the atmosphere based on how much capital and how much labor they use. So they are able to essentially hire either more labor or more capital to reduce pollution, and we're going to see that's important in a moment. So I put a corporate income tax, a carbon tax, and a tax swap all in the model. And the most important thing here is that because in my model there's no profits, it's a very, very simple model, we represent the corporate income tax as a tax on the capital that the firms use. So that might not mean a whole lot, but there's important interpretation that's coming down the road with that. We have a per unit carbon tax and then a tax swap that takes all the revenue from the carbon tax and equally distributes it between the two firms to reduce their corporate income tax. So after you kind of define a model, you go ahead and solve it. My model consisted of 11 simple equations. And once I sort of solved through everything, the key result was that the only thing that's impacted by this specific tax policy is capital in my model, which was really surprising. You would expect that having a policy that takes so much revenue from the economy and then distributes it in an odd way, you would sort of expect to see those effects throughout. However, because the corporate income tax is only placed on capital, we only see the tax swap effect in capital, and I'll illustrate that more in a moment. But this sort of implies that my results are kind of specific to this model, and so economists might stumble upon this along the way when they're kind of doing this research. They might realize, okay, maybe the tool I've selected is not completely generalizable, but there's still some interesting interpretation to be had. So once I solved the model, you input some approximations for what the real U.S. economy is like. In this case, we define the specific sectors in the carbon sector. We set the tax rates based on suggested values and also values that we see in the real U.S. economy. And the data I'm using is from 2008. But very specifically, if you remember, I said the dirty firm can substitute between capital, labor, and pollution. They can choose how much labor and capital and pollution they use. In the economy, there's this Jorgensen Group paper estimates that capital is a better substitute for pollution. So firms, it's much easier for them to buy more machines, put in more technology to reduce pollution, and so that's going to have really big implications for our results. So you take those simulations, you sort of run them through, and then you kind of, I don't know why that didn't, those are supposed to be longer words down there, but you run them through and then you sort of examine the output and see if the changes are sort of in the directions that we might expect. And so on the left, I'll just have to read these out because the titles got sort of axed, but we have the price of the dirty good, which the carbon-intensive good, which increases. The price of, we also see a decrease in carbon emissions, and then we see a slight increase in wage. And those are all values that we would expect for this specific type of policy. What we don't expect, and what was really surprising to me, is that capital actually benefits in an enormous amount. If you look at this bar graph here on the right, the corporate income tax decreases by 120%, which is an incredibly large magnitude. And with some sensitivity analysis, I was able to determine that that is essentially just because of the different sort of settings in the model and the industry. But it's an indication that under the specific setup of the U.S. economy, we might expect to see some pretty drastic effects from this policy. In other words, it'd be very, very effective at redistributing this revenue. And in other words, and this is kind of, I think, sort of funny, it actually decreases the corporate income tax below zero, so it turns into like a subsidy, like a handout to firms, which is not necessarily the objective of such a policy. So essentially, what you would do after you kind of look at and analyze these results is you want to make sure that they're robust. And so economists will essentially vary parameters that we choose, because I want to make sure that the numbers that I'm choosing are telling the story that I want them to, and that my results actually stand up to variations in anything that I might have selected. So I'll draw your attention to this one for time. Essentially, what I'm doing here is changing essentially the magnifying glass, like the scale at which I'm looking at the problem. So the study, that all those numbers that I just showed you, that was when I changed the carbon tax by a 10% level. So what happens if I change that like 100% level? What happens if I look at starting level at $15 and look at how it changes at $30? All we see is that the magnitudes sort of grow really linearly, but essentially we just see the effects are magnified with whatever sort of window I'm looking at. So essentially what that means is like you don't have to take the magnitudes of the effects as essentially, we shouldn't expect to see 120% change if we have a very small change in a tax. So it's just an important note for scale. And so in conclusion, the tax incidence of this very specific policy is really dependent on how we use the revenue and how it's recycled. And this could result in a subsidy in the U.S. economy, although that's not necessarily likely to happen, especially because my model, as I found, was pretty specific to, essentially it's very self-contained, just the way it's designed. But I think what's really important here is that the ultimate goal is to contribute to a larger body of policy analysis. So future studies can actually use the same basic model that I've used with slight alterations, and then experiment with different sort of permutations on the same policy. So you can compare, for example, what happens if you decrease personal income tax as well, and sort of see what the effects of that are. Because ultimately, we would like to understand in which ways the U.S. economy is really vulnerable to a policy, and in which way it might actually, a policy like this, in which way a carbon tax might actually adversely impact it, and then in what ways we can actually mitigate those effects as well. So thank you very much for your time. All right, any questions? Professor Premack, yeah.
So are there any states in the United States or are there countries where they've actually implemented a carbon tax, and has it had the effects that you're predicting?
So I believe so. I think one anecdotal example would be around Vancouver in Canada, British Columbia, and they've implemented a carbon tax. I believe Australia has a carbon tax program, and they actually see. So to be clear, what I'm studying is not something that's really been implemented anywhere. It's just a sort of the policy I was examining is something that you could do if you were going to implement a carbon tax. But most countries actually hang on to the revenue and don't redistribute it. But there's been a lot of research and literature that shows that, depending on how you use that revenue, if you maybe use it as an earned income tax credit to low-income workers or something, you're actually able to avoid a lot of the adverse effects. So to answer your question, no countries have actually used the revenue from a carbon tax to offset adverse effects in reality or in real life. But we probably should look into doing something like that. So, yeah. Anything else? Yes.
So in your case, you recycled all the revenues, so there is no bottom line, actually.
Correct. Yeah, it's a revenue neutrality constraint. So there's no revenues held by the government, especially because this is just there's no time in this model, so all the revenue that's sort of taken in is recycled. And then I should say also, maybe practically and in reality, there might probably be a combination of ways that a government might actually recycle revenue. There would probably be incentives for the government to offset the personal income tax for low-income workers, or even just use it as a subsidy for them, and then maybe use a portion of the revenue to lower the corporate income tax for various other efficiency effects in the economy. But it's really hard to model that in a simple way. And essentially, another study tried to kind of maybe approach that a little bit, but as soon as you start to answer a bigger question, the number of equations in your model just balloons up, and so you don't have the same sort of interpretability. So that's why it kind of had to be sort of extreme. But thanks for your question. Yeah. Thank you.